In this video, I am going to try and provide you with a better description and some more drawings, something that maybe will make a little more sense to you than it will if you're actually looking at the information in this pamphlet. Now, the information I'm going to talk about in this video will be for how to support the bottom of a stairway coming off of a deck. So for an exterior stairway. And this is what the American Wood Council recommends. And I'm not going to put a link in the video or in the video description box, but I will put some information that you can put into the search engine and a page number that might be helpful to so you don't got to go through the entire book trying to find it. But what they have in the book is just a small I think they have 4 details, and they're real small, and it's kind of hard to understand what in the heck you're looking at. So I went ahead and drew something, and hopefully I'm right on this with my interpretation. But this is actually what they're suggesting for a stairway without a handrail. I will put some more information at the end of the video, towards the end of the video, on what they're suggesting and recommending for a stairway with a handrail. So they're basically asking for a 10-inch by 10-inch by 6 inches deep concrete footing, or a 12-inch diameter, 6 inches deep concrete footing. So either one of these will be fine, and the minimum distance into the ground needs to be 12 inches. So from the top of the soil to the bottom of the footing needs to be 12 inches. That's the minimum that they're suggesting. And then, of course, we'll go into what they want for soil with frost lines here in a little bit. So a 2x4 nailed to the 4x4 with 8 16D nails, or 8 3.5-inch long number 8 screws, and then 2 of the same, either a 16D or a 3.5-inch long number 8 screw for the attaching the stringer to the wood post. They also recommend that the wood post be cut to the bottom of the tread. So it would look something like this is what they're looking for. And I would imagine they have it kind of like this on the outside. I don't see why it wouldn't be a problem for you to put it on the inside here if you want it to look a little nicer. Seems like it would work out just fine. So I went ahead and moved this one back too. You can see that from the front of the stringer, probably about 3 or 4 inches back. And here I have it almost to the front. But you can see here, if this lumber was to split here, this thing's going down and it's a problem. So they did not suggest where to position this on the stair stringer. You know, my thought is if you move it back, it could actually, the front could break off. If you move it to the front, the back section could break off. So not 100% sold on what to do there. And again, I'm just providing you with a better interpretation of their example. I will make other videos if you want, looking for a little more information on what might work better, or even a different type of stairway that will work better for something like this. So this is what it would be without a handrail. So if this post was to go up and it had a handrail on here, then this would be would require a different assembly method. Now let's go ahead and take a look at what would be required if you had a frost line. So if you live in an area where the ground freezes, and if the ground freezes, then the soil could be pushed up. And if that's the case, it's going to raise the stairway and raise the footing. So they want the footing, the bottom of the footing, to be below the frost line. So, you know, an inch below is fine. So let's just say in our example here, we have a 2-foot frost line. So they're suggesting if you live in an area like this, the ground within 2 feet is going to freeze and could force things up. Below that, you shouldn't have a problem. So that's what the frost line is looking at. And same thing here, the 2x4 support, the 8 nails or screws, you can space them apart. And then of course it will have 2 nails or 2 screws to fasten the stringer to the post. What it would look like when it's filled in. So this would be an example for a frost line, if you had soil with a frost line and no handrail. Next up, let's take a look at what would be required if they have a post. If you have a 4x4 post that is going to be used to help support a guard railing, something that a lot of times you come to a stairway like this and it's not very strong, and it might not be very strong if you just go down 12 inches in the ground. You know, if this thing is 2 feet into the ground, it's going to be a different story. But you're also going to have to make sure that it's stabilized on the footing somehow. For the examples I looked at provided in the pamphlet from the American Wood Council, they did not provide any type of building hardware supports. So you might have to put some type of a base connector in here, or something to prevent this thing from moving. So keep that in mind also. So let's get back to what they require for a post that's going to be used as a handrail. Same nailing schedule for the 2x4. Only difference is going to be that they require 2 1/2-inch diameter bolts to connect the stringer to the post. Another view of it there. Now I would like to point out that any lumber buried underneath the soil is going to need to be ground rated treated lumber. So keep that in mind also. You just can't bury, and I know a lot of people too, a 4x4, some cedar, the termites aren't going to get to it. Well, there are so many words that are misleading, and if we listen to the government, we can get a nice, or the newscasters, we get a nice fill of that. But it's no different in the construction industry. Decay-resistant lumber, I've seen it decay. I've seen it rot, and that's why they use the word resistant. Otherwise, it would be decay-proof. Waterproof, water-resistant. Well, I'll tell you what, the lumber here, if it's not ground-rated, pressure-treated lumber, then you're probably going to be replacing it over time. So just keep that in mind. They did not mention that in the book, and if they did, they might have mentioned it earlier on in the book. I didn't see it. So just pointing that out. This is definitely a plus, and they're not going to argue with me about that. They're going to be agreeing with me for that statement there. Now, if you're with the American Wood Council and you're watching this and you see any problems with something that I suggested, feel free to share them, leave them in the comment area, and I will address them as soon as possible. Now, I do want to point out one thing. Even though this is a suggestion from another organization, it might not meet your local building codes. It might not be something that they're using, and they have their own reasons why. Always check with your local building department to verify any of the information you see on our websites and other websites as well. I mean, the last thing I want to do is provide you with some information from somebody else. I'm kind of like a middleman here. I'm providing you with an interpretation that might be difficult for most of you to understand by looking at the two-dimensional drawings. So these three-dimensional stuff I can do really makes a difference. So that's it for the video. Let us know what you think by hitting the old thumbs up button, and feel free to share any experiences you've had with us about situations like this. I know a lot of people I've been talking to lately have had the stairways heave, and they've lifted up and separated, broken away from the edge. And I know it's not a huge problem, but if we can just reduce the possibility of stuff like that happening in the future, then we could actually be building better stuff, and that's going to translate into less accidents in the future, or problems with our buildings. In this video, I will provide you with a few ideas that can be used to build a stairway on a hillside that might be steeper than 35 degrees. So if you have a standard stairway that has an 11-inch tread and a 7.5-inch riser, you're going to have 34.3 degrees. If your hillside is somewhere close to this, somewhere between, or let's just say under 37 degrees, maybe even 38 degrees, you're not going to have a problem. But if you do have a hillside that's a little steeper, you might be able to solve your problem by just putting a retaining wall in and then changing the direction of the stairway. So if we came up, changed the direction, and then went back up again, this type of stairway right here allows us to put a stairway on a hillside with a 39.1 degree angle. So we couldn't really do this. You could build a stairway. It's just not going to be as safe as this particular stairway. Another thing you might need to do will be to add additional retaining walls. And here we have one coming off the side. So your retaining walls, and even if you're going to build curb walls, like this here, and of course this right here is going to allow you to put a slope here that isn't going to be as steep. You know, if you have maybe a 35 degree angle or 40 degree angle, and then it's got to drop down to a 50 degree angle and then back to a 35 degree angle, something like that. This could be a problem area here. So, you know, building a set of stairs on a hillside like this and making it safe is going to require more than one retaining wall most of the time. And that, of course, is to keep all of the debris and, you know, sand, leaves, stuff like that, to prevent someone from slipping on this stuff and injuring themselves. Another idea would be to have the curb wall run all the way up, if that would work for you. So another idea that might save you some time and money, and of course provide you with a nicer looking stairway. And for those of you who have a hillside that has a steeper slope on it, a retaining wall at the bottom might be your answer. And of course, here I have a concrete set of stairs. You can always use wood on the other side of the retaining wall. You can always use wood up here also. Just make sure that it's the right type of wood. Sometimes pressure-treated lumber, if you're going to be putting it on the ground, needs to be ground rated. So that's ground rated pressure-treated lumber, not round, ground, G-R-O-U-N-D. A lot of you go down to buy pressure-treated lumber at your local home improvement center or something like that, might not be the right lumber. So check that out and make sure. So the retaining wall height and location is going to be critical to your design. And let's just go ahead and start out with an angle here, 47 degrees. That's a steep slope. And this area here, of course, is going to get backfilled if you did have something like this. So again, retaining wall, you can always build a wood-framed stairway to save yourself some money after you've just put your expensive retaining wall in, of course. Now let's go ahead and remove the stairway, give you an idea. I know a lot of times it's hard for people to understand or get an idea of what I'm actually doing when I've already done it. It's already been completed. So here we have an existing structure. Here's the stairway. And again, you can take this, you can see here where you could move this entire section this direction or this direction. You could cut into the hillside if you needed to, or you could move it over here if you had a steeper slope. So if you had like a 50-degree slope, it might benefit you to move it this way and then build a longer stairway here. And then you would simply backfill this area. So the backfill, of course, can be soil, can be compactable soil, fill, stuff like that. Gravel's what I kind of have here, but you're probably not going to backfill something like this with gravel. It's going to be a material similar to the one that you have here. It's just that if it isn't compacted, then you could have problems with your stairs if you have any structural support in this fill area. So for example, if you're going to put some footings, it might be better to put the footings in the area that the existing area that has not been disturbed. If you put a footing in here, a structural footing in this area, and the soil settles, well, then your footing is also going to move down and could create problems for your stairway. Now here's a situation that I referred to a few seconds ago where if you might need to move the stairway out a little further. Here we have a 60-degree slope. And of course a lot more backfill in this area. And of course we had to move the stairway out a little bit, but it still kind of ended up in the same point. So just another idea, of course. Now here's another situation you could run into where you wouldn't need a retaining wall. You could build a set of stairs. We have a 29-degree angle here. But this right here, you can see I left the stairs in here to help you figure out what I was doing here. But this is going to provide us with more level area in the backyard. So if we remove everything, let's just go back and then go back again. You know, we're going to be removing some of the hillside and building a retaining wall and then getting more level area in the backyard. And I remember I knew a guy who did this one time. He was putting a pool in his house and he built a retaining wall so that he could put a pool with a waterfall on the side of it. Really looked neat the way that they did it. So same situation here. Retaining wall again is what is going to allow you to do something like this. So hillside here with the stairs already built to give you an idea how much you would have to remove. So this would be the amount of soil that would need to be removed for your stairway. And this is our last example. So again, building stairs with retaining walls on hillsides could be the answer that you're looking for. In this video, I will provide you with a couple of methods that can be used to measure the height and the length to see if a prefabricated stair stringer will actually work or it will not work. Now keep in mind, the height of a deck, the height of a platform, needs to be a particular distance. And it can't be off very much. If it's off more than 1/4 of an inch or 3/8 of an inch, you're probably not going to be able to use the prefabricated stringers. So if you do have a situation where the prefabricated stringers won't work, go to our website, homebuildingandrepairs.com, and click on the Books tab. That should take you to some books we have on stair building. I would recommend getting the book, How to Build and Frame. Straight stairs, unless you're going to be building stairs with a landing, or the other stair books that we have on winders, circular stairs, and odd-shaped stairs. Check them out, and that should provide you with step-by-step instructions. So back to the prefabricated stairs. They not only does the decking need to be a particular height, the distance that you're going to be traveling needs to be a particular length also, or an exact length to make it work. And I did notice that they sell smaller stringers and longer stringers. And I also don't like the fact that they're kind of cut out of 2x10s. I seen that it said that it was 9 inches wide, so that would be measuring it from here to here, the farthest point on the stringer in width, and I didn't like that. It just creates too narrow of a spot or a distance here where there's not enough strength. For smaller steps, maybe 4 steps or smaller, 2x10 might work just fine, but I have never built a set of stairs with a 2x10, and I have built over 1,000 stairways, so keep that in mind. And I am not promoting the use of these stair stringers because they only work in specific situations. I will actually have a link in the description tag or comment area to Amazon. And if you don't see the link, that means that it was removed for some reason, but I will put it in there. And if you're looking for prefabricated stringers, you want to get them on the internet, feel free to check those out. However, I would recommend going to your local lumber yard. That way you don't have to pay for any shipping fees. And who knows, if Amazon's cheaper, knock yourself out. If it's a little more money, pick it up at the store and save yourself some shipping. fees. So here we have two different situations. The top of the stringers even with the top of the decking. And here we have it where we're using the decking as for another riser. So here we're going to have a situation where we have 4 risers, 1, 2, 3, 4, and 3 steps. And this situation we have 2 steps and 3 risers. So keep that in mind. They will work for 2 different heights if you use either one of these methods here. Now let's go ahead and show you some measurements here. 6 3/4 inch risers. They are 10-inch deep treads or 10 inches long. 3 of them will be 30 inches. And if we have 4 risers here, it's going to be 2 foot 3 inches or 27 inches. Take a look at the length, and this is what I'm talking about. It's got to be a particular length. If you needed it to end here, and it was going to be starting here, but this length was 34 inches, this isn't going to work. You're going to need to cut your own stair stringers. So again, you can start to see where this right here is only going to fit in a specific height. And this, of course, is an excellent example of what I'm talking about. I added 2 inches to the top of this, and you can see where it is not going to work here. And of course, it will not work if I make the platform 2 inches shorter either. So hope this is starting to make sense why it's not always going to work. And I really don't know why they make prefabricated stringers, except I do understand that some people are going to build a set of stairs and it is going to come up to a deck that's a little taller. And they're just going to go ahead and have a small step going up to the top. I've seen that plenty of times. Is it going to, be the end of the world if you do something like that? This, obviously not. Something like this, you could always cut this one off and slide it in and use the 2 steps and then have a shorter one up here. If that was what you wanted to do. It wouldn't meet local building codes. I'm not going to suggest that it would, but I have seen this done plenty of times. Now, for those of you who get it, you understand, you don't need to hear any more of it. You can stop watching right here. For those of you who need a little more information, I will go ahead and throw it your way. So let's start with a pre-manufactured stringer that has 5 10-inch steps, and then one was 7. Now remember that even though this has 5 individual steps and we're using it for this measurement here, that this one only has 4 steps, and then we come up to the landing. And if you needed to make it, let's just say that you had your distance here was, right now we got 5 steps, so that's 50 inches. 1, 2, 3, 4, 5. 5 steps at 50 inches. Go back to the beginning here. And if we needed to make this smaller, we got the room here. We could actually make this thing almost 10 inches smaller here using this particular stringer by simply just removing some of this. If I had 48 inches, I would just need to remove 2 inches from this side right here, and everything would work out. So another tip there for something like this. The length might not need to be as exact as the height, of course. Now, if we're going to add our next step to this one here, it's going to change the height of the platform, of course. Just giving you another example there, trying to make sense out of this to people that are having a difficult time with it. Now, that is it for the video. Pre-manufactured stringers are not going to work for everyone. Here is another viewer requested video. The individual wanted to know, what is the minimum height for a riser? And that is it. 4 inches is actually the riser height, and that would be from the International Building Code book. You, however, will need to check with your local building authorities, your local building departments, to verify the information in this video. I know a lot of people make a lot of videos, and there's a lot of stuff on the internet that is not true. And what the information I'm providing you with here is information that came from a book that might be used by your local building authorities. I mean, I'm in the United States, I'm in California. This is a common building code, but I could actually be in a city or a county in California that doesn't have this. So now the state of California actually does have its own building code regulation. So that might not be as applicable in California, but in the state of Nevada, it might be. So always check with your local building authorities. The information that you get from my videos or other people's videos needs to be verified. And if you don't verify it, you could end up with some problems in the future. The maximum riser height, 7 3/4 of an inch. And this is this would apply to stairways in residential homes, for example. I believe the building code book that I got this information out of, 2018 International Building Code book, I believe that it refers to this as an occupant load of less than 50 people. But if I say that, I realize it can be confusing to some people. I mean, let's say that you're in a public building, a commercial building where you have a restaurant or a bakery, and there's only 5 people that work there, and you're thinking, hey, wait a minute, these codes apply to me. No, they don't. Completely different codes. And the minimum riser height for public, or I don't want to even use the word public, but more or less public buildings is 7 inches. So, and the maximum or the minimum tread width for a public building is 11 inches. For a home, residential building, it is 10 inches. So hope that makes sense. Now, the biggest problem you're going to have when you build something out of the maximum, everything's going to be 7 3/4. I need to point out is that you cannot be 1/8 of an inch taller. The inspector measures this, and it's 7 7/8. You could be tearing this thing apart. So it's probably the best information you're going to get in this video. So pay attention here. Same thing with the minimum. If you're building a minimum riser and you're going to make it 4 inches, if it's 3 3/4 of an inch, you could have a problem with your building inspector. You're going to be tearing the stuff out or fixing it somehow. So anyway, that is it for the video. I think I'm going to refer to this video as a public service announcement because it's a question I keep getting over and over again. And that is, can you build stairs in tight spaces with extremely tall risers and shallow treads? And can they be like 24 inches wide? This is actually a question I received just recently. The individual wanted to build a set of stairs that had a 10-inch riser height, 8-inch tread, and it was 24 inches wide. And yes, you can. You can do whatever you want. You can put a ladder there if you want to. The only problem is that your local building department might not like it. You are going to have certain building codes that you need to follow. Now, with that said, and you need to check with your local building department to find those building codes or watch some more of our videos. But this video here, I just want to focus on some of the problems you might run into if you do build a set of stairs like this in a tight space. And number one thing, make sure you have a handrail. This is a must. Make sure that you have a handrail that you can hold on to while walking up and down this type of stairway. And hopefully by the time you have finished watching this video, you will understand why the building departments, why these people have worked this stuff out for your safety and your protection. So again, if you have to build a set of stairs like this, you do not have a choice. I understand. It's just not, you're going to have to be careful using it. You have to understand the local building department isn't going to approve it, or I should say most of the time. And the reason is just because of safety. You fall down one of these sets of stairs once, and you're going to think, why did I build it like that? Why didn't I listen to that guy that made that video? So pay attention here. 8-inch deep stair tread, 10-inch tall risers, and your feet are only 10 inches. So these little shoe samples I made are 10 inches. 2 inches of the shoe is going to be sticking off if you butt the shoe up against the riser every single step you make. If you keep your shoe about an inch away from the riser, now you are going to only have 7 inches. Now this isn't that big of a problem when you're walking up the set of stairs and holding on to the handrail. But things are going to be a little bit different when you walk down a set of stairs like this. Unless, of course, you walk flat-footed or with your heel first instead of the front of your foot. And most people are going to be walking down a set of stairs with the front of their foot setting on to the front of the step, not like this. You're not going to back your heel up against the riser every single time. And I'm saying this, I'm pointing this out for a reason. Just like I pointed out the handrail. You are going to be, when you're walking up the set of stairs, you're going to want to be propelled forward. If you fall, you're only going to fall a couple of feet because you're going to fall face first into the stairs and you're leaning forward. If you are walking down the stairs, you're going to be propelled forward in the opposite direction. And you're going to be falling a lot further and probably going to be injured a little more than if you just fell a couple of feet. You fall from here all the way down because you're walking down the stairs. You slip up here, you're going down. If you're right here and you're walking up the set of stairs and you slip, you're just going to fall over to here maybe. Up here and walking down, it's going to be totally different. So, as I said, if you do have a situation where you have to build a set of stairs like this, and you are not going to pay attention to what your local building department says, you're going to build a set of stairs anyway, you have to. It's a tiny house, whatever, I got you. Make sure that you have a handrail. And I would definitely advise getting used to walking up while you're holding on to the handrail. That means hold on to the handrail. Firmly hold your right hand, you're walking up the stairs, your right hand is holding on to the stairway. Then you move your feet. Then you wait. Then you move your hand. Then you take 1 or 2 more steps. Then you move your hand again. Don't just hold your hand up here as you're kind of walking up here. These stairways are they're dangerous. And I remember I had to build one time with an 8-inch step and a 9-inch riser. And this is when I noticed it. Walking up the set of stairs wasn't that bad, but walking down the set of stairs, and I didn't have a handrail. Remember, I'm building the stairs. All we have are some wall studs to hang on to. And trust me, I hung on to those things with my dear life while I was walking down them. And I just couldn't believe more people didn't get injured. And I understand we can be cautious. We can be safe. And that's really the bottom line in this video. If you do build a set of stairs like this, you have to understand that you're going to have to be careful using them. And every other single person who uses these set of stairs, your pets, your children, your parents, your aunts and uncles, elderly people, young people, they are going to have to be extra cautious. And that is every single time you use this set of stairways. And of course, let's not even throw in the alcohol and drugs and other things that can lead to even more problems using a set of stairs like this. So here is another video that is going to be another attempt of mine to make the process of building stairs a little easier. And I think that this right here just might make the biggest difference for those of you who are trying to build a set of stairs with a landing. Now also, don't forget to check out our book and our book packages on how to build stairs with landings. And of course, the book package deal, definitely recommend getting the double book package with the laying out the stringers. Definitely going to help. It'll explain how all of the stringers are connected, what's going to be the best way to make the connection for the type of design that you are going to be working with. So let's go ahead and get started here. Take a quick tour around here. The upper stairs is located over here on our floor plan. Lower stairs over here. Here's the landing. Another view of it there. And the reason that this is going to be helpful for people who are having a difficult time, and I hate to say this, I have seen a lot of people who build stairs and they know what they're doing, got a pretty good idea, and they still would be better off if they actually snapped all of these lines or drew these lines on top of the building foundation or the floor sheathing. I cannot tell you, because you can use these lines as reference points to double check everything while you're building. So that is the key to this video. Putting a floor plan type diagram on the floor where the stairs are going to be located. And hopefully by the time you're done watching the video, it will all make sense to you. So top of the top view of the stairway, upper stringers, upper steps, and this would be the upper section over here. Now the floor plan, if you're working with an architect or a building designer, it's going to have an arrow showing which direction that the stair travel is going to be. So it might have an arrow and it'll say up on the lower floor plan. And then it'll have an arrow pointing down on the upper floor plan to give you a idea where the stairs are and how they are functioning on that particular plan. Now let's take a look at what it would look like with the floor plan drawing underneath the stairs. We can see where the front of the stair riser here lines up perfectly with the line here. Go around, we have the landing here. So all of these lines are going to line up here. Very important. Now for those of you who just aren't quite grasping the idea why in the heck this floor plan is so important, let me see if this makes sense. I'm going to go ahead and draw some boxes in here. The boxes will represent the step. This is the top of the step here. The other side is going to be the front of the riser. Now remember that the front of the riser is going to be the face of the riser. This might not represent the face of the stringer or the knot you're going to cut in the stringer. This is going to represent the front edge of the plywood or whatever materials you're going to use to create the front of your riser. So here we have the front of our riser and the top of our tread, and it needs to fit within this box in our layout. Now let's go ahead and throw another box in there. We can see here again, front of the riser, top of the tread, and this of course is the third step up. So the measurement, when you are done, when the stairway is completed, top of the tread is going to be here. Front of the riser, face of the riser is going to represent this area. If you're going to use 1/2-inch plywood, then on the stringer, before you put the plywood on, you're going to be able to double check these measurements, get a level, come up and see if the stair stringer is a 1/2-inch back for a 1/2-inch riser. If you're going to use a 3/4-inch riser, the stair stringer will need to be 3/4 of an inch back so that when you nail the 3/4-inch thick riser onto the stair stringer, the front of the plywood, front of the OSB, front of the riser, face of the riser is going to line up with these lines. And of course, this is what it would look like if you had the stringers, front of the stringer lining up with these lines. You're going to nail your 3/4 inch thick plywood on top, and it's going to be sticking past. So again, this isn't difficult to do. Before you nail the stringer into place permanently, set the stringer in place, attach it with some screws maybe, and then grab a level and double check everything and see what position, make sure that all of these lines line up. And you might even benefit from, if the stair stringer was cut incorrectly, you'd be able to see it right here in the lines that you have. So if you snap 10-inch lines apart on the ground and you, for some reason, laid out your stair steps at 10 1/4 inches, you're going to see it right here. But that isn't going to be the case, is it? Because you now have a valuable tool here to figure out exactly where to position everything correctly, right? So we're not going to end up with that problem. Now, I did move this landing back a little bit. Let's go back. I moved it back 2 inches. You could see here. This is something, again, you're going to have to adjust if you have a overhang for your stair treads. If you have an undercut for your risers or your steps, you're going to have to set this back 1 3/4 maybe, 2 inches to get everything to work out. So keep this in mind also for your landing. Just don't build it at 3 foot. That's one of the worst things you could do. You know, come in and, hey, you know what, my landing's got to be 3 foot. Well, it can be 3 foot as long as you have square risers, as long as you don't have any overhangs for the treads, any stair nosings. No nosings, no undercuts. Yes, then you can have it, build it at 3 foot. If not, then you're going to have to adjust and compensate for every single piece of material in your stairway to get it to turn out right. In this video, I am going to provide you with an example of what your stair stringers could look like if they were off by as little as 1/16 of an inch per riser. So let's just say that you figure out, you get the total rise of the height between the floors, the top of the first floor to the top of the second floor. You do the math and you come up with a fraction and you just kind of round it off to maybe 1/8 of an inch when you should have rounded it off to 1/16 of an inch. So hopefully this will make more sense of what actually happens to the stairway by the time you're done with the video. So what I'm going to start with are 3 different stringers. This stringer here has a 7.5 inch riser height, individual riser height. Each individual riser is 7.5 inches. This one is going to be 1/16 of an inch larger, 7 9/16. This one here is going to be 1/16 of an inch larger than this one, 7 5/8. So we got 3 different stringers and the same length. And I'm actually going to use the center stringer for our experiment. So this line right here lines up with the center stringer, and the top of the floor is going to be lining up with the center stringer. So here we can see where there is a difference. There are 7 risers. So we actually have 7/16 of an inch, almost a 1/2 inch. 8/16 of an inch is a 1/2 inch. So this one here that is a little taller is going to be, or has the risers that are a little taller, is going to be a little taller. And this one here, of course, is going to be a little smaller. But without you knowing what's going on, you're going to end up taking the stair stringer and nailing it to the top of a ledger or the top of a floor like this. And actually, you're going to end up with a gap at the top of this one. And you're going to end up with a gap at the bottom of this one. We can see the gap here because now we are at 2 different angles. So each one of these each one of these stair stringers has a different angle. The one that is 7.5 inches is 37.5. This one here, the center one, 37.1. and then this one here 36.9. So just kind of remember those measurements. I'll remind them again later when I bring up another point when I go to longer stringers. So here we have a gap at the front, and it's tight at the back of this one. Another view of it there. Hopefully that makes sense. And of course it does with the angle, if you think about the angle. And you can also see that this, even though we haven't changed our tread measurements, these are exactly 10 inches. It's going to push this out a little bit. Now, when I'm saying this, these are computer aided drawings, and they're usually not wrong. And this is something I remember running into on job sites. If I didn't cut the stringer the right height, I mean, the risers didn't figure them out correctly. Precisely, exactly precise measurements for the risers. They've got to be, if this comes to, like I said here, if this is 7.5 inches and, or 7 9/16 is the measurement you should be using, but you use 7.5 inches, you're going to end up with this. And you're going to be wondering, why in the heck is this thing off? I think I checked this and it was off, I want to say almost a ½ inch. I think I checked. I think we'll have a measurement on that in a little bit. Now, of course, here we have a gap on the back of this one. So the gap on the front of the other one, the one with a 7.5 inch rise, we have a gap in the back. And of course, this is what you're going to be looking for. You set your stringers in and you have a gap in the front or the back, grab the level, check the treads and see if they're actually level, or if there's a problem with your calculations on your individual riser heights, and you might have made a mistake when you were laying it out. Either way, you make a mistake through the math, or you make a mistake when you figure the total rise, or you make a mistake when you are laying out the stair stringers. This could be a problem. Now I went ahead and I drew a level line, and this I believe was about a 1/16 of an inch. But if we level a line across this one here is going to be level. This is what we figured the height, and everything works out correctly for the center stringer. This one here, the stair treads are going to be leaning forward. The one on the other side is going to be leaning backwards. So again, this isn't difficult to figure out. You put the level on here, you're out of whack, something's not right, double check all your measurements. Now this is where I actually learned something. I thought that these measurements would have changed. It's still about a 1/16 of an inch here, sloping backwards. And of course, this is a longer stairway. The degrees of these stair stringers have not changed at all. And if you think about it, they shouldn't have. It's the same rise and the same tread height, just multiplied by this many more stringers. So treads and risers. This stringer could have 100 steps on it, and it would still be at the same angle. All three of these would be at the same angle if you were working in this particular instance. However, the measurement on the bottom is going to grow a little longer, and I really don't know why that is, but I checked the other one. And this one here that's 9/16 of an inch, on the one with only 7 risers, it was 1/4 of an inch. So this actually grew a little larger here, even though the angle hasn't changed, and we still have the same gap. And if you know the reason why that changed, or if I made a mistake with my drawings here or my computer-aided software, feel free to let us know. I am always open to any constructive criticism, as long as it's constructive. Let's not get carried away. But the gap didn't seem to change here. So realistically, on the longer stairway, we still have the same angle. We just have a little variation, a little more at the bottom than we would if it was a shorter stairway. And I can't really wrap my mind around the reason why that would be, just that it actually showed up in the drawing. So that is it for the video. If when you're laying your stair stringers out, and you're especially on a longer stairway, this isn't obviously going to be a bigger problem on a longer stairway if it's going to be the same angle. But if you want your stair treads to be as level as possible. Make sure that you lay your stair stringers out to possibly within a 32nd of an inch, if that's what it's going to take to create a nice level stair step for the entire stairway. Here is a video that is kind of a challenge, and hopefully it will help some of you. In the United States, we can get lumber in a variety of different sizes, but a little while ago, an individual asked if I could build a stairway entirely out of 2x4. And they said that that's the largest piece of lumber they can get in their country. And I didn't ask what country it was in. I do know that someone emailed me from Israel one time, and they were having a problem. I think a 2x8 was the largest board they could get. So if you know what country that is, feel free to share it in the comment area. But I'm going to go ahead and get started. And again, entirely out of 2x4, and you can use screws or nails to attach everything together. And to give you some measurements here, 7-inch risers, 10.5-inch wide treads. If you want to leave an 1/8 of an inch gap between everything, then the risers can be a little taller and the treads can be a little wider. And what I'm going to do is take the stairway apart and then put it back together. So it's just going to be a process. I know it's a lot of people, when they're doing how-to videos or how-to books, they just show you from a blank spot, maybe just the concrete here, and then they build it. But I think it's better to tear it apart and put it back together. And again, with these videos, it doesn't take long to do. So let's tear this thing apart. So it'll give you an idea of what you're actually going to be building when you put it together. Take the risers out, and then we can pull this down here. So you can see in this video here, I'm actually going to do this a little different. I'm building the sides up in this one, but when I put it back together, I'm going to be doing one step at a time. So you can do it this way here if you just reverse the process, or you can do it this way. So we're going to start with our bottom board here, and then put in our braces, and then we're going to put our riser in, and then our tread. So we're just going to kind of work our way up. In the other one, if you remember, we didn't put our risers and treads on. We built the side of the stairway first, but this way right here might be a little easier. Risers, and another view of it there. Go ahead and put a couple of more support boards in. And these braces here are critical. They're going to hold this together, and you might actually need to put a couple of them over here. If you think it's going to be weak, it wouldn't be a bad idea to put another brace in. And that can always be done after the stairway is built. But, while you're building it and you get to a certain point, and you're not going to be able to get to it from the back. Even like this point here would be good. You could come in here and just put a brace in here, or have it come up a little bit. Let's move it back there. You could have it come from here down. This would kind of be in the middle. So it would start up here and then go down to here, and that would stiffen this up. But as you nail everything together, you're going to see that these boards and these boards here are going to strengthen everything up. You're going to have a nice connection here. You're going to be nailing or screwing into the braces, or through the braces here into the other sideboards here. I'm going to show you more on the nailing here at the end of the video, give you an idea. And again, if you have any questions, feel free to leave them in the comment area. I know that when I'm building this stuff and on the computer, I can see, okay, this is a problem, like I'm doing here. I didn't put the riser in here because I need to be able to get this top support brace in. I need to be able to attach the brace to these sideboards here. So you can see here, if I put this board on, I could still get to it, but I'm not going to be able to get to it if I put the top treads on. So you could always put the riser on here, as long as you're going to be able to have enough room to access some of these other spots, and then simply cap it off and you are done. But don't turn the video off yet. Let's take a look at how we would nail or attach these. You can use nails or screws, whatever you feel is going to work best, and simply nail. And I don't think one nail is going to be enough for a 2x4. You're probably going to need 2 nails. Center them on the where you're going to be nailing into these boards below it, and maybe about 1 inch or 3/4 from the edge. And if it splits, pull the nail out and move it over a little bit. And then, of course, you can nail down the front of this to connect these 2 boards together. And the risers, again, 2 nails. And then the brace, you can use 1 nail per board, or you can use 2 nails per board, or use 2 nails, 1 nail, 2 nails, whatever you feel, or screws. And, of course, you can always nail the back of the riser into this tread to create a stronger step. Without these nails here, you might not have a very strong step. And if you're worried about this one here, this one's going to be sitting on top of here, and then you're going to be screwing this. You're going to be making this one here a little stronger, but this one here in the middle might not be stronger. You might need to put a board on the bottom of this and screw it from the top, or screw it from the bottom, or even a couple of support braces in there to get a little stronger connection. And again, if you have any questions about that, feel free to leave them in the comment area. That is it for the video. And something like this seems like it would work. If you do build something like this and it's not working, it doesn't work out, let us know what you're having a problem with. A lot of times I'll draw something on the computer, and this is something I've never built before physically. I just kind of trying to help somebody out in another country who can't get larger pieces of wood. You might have to work with something like this. And in order to work with something like this, you might have to modify it, in a certain way. And again, I have 2 kind of braces here. And this is a 3-foot wide stairway. And like I said, if this right here is going to be a little loose, you could always put another one of these support side stringers, let's say, in the middle. And you would use 3 of these, and that would take the place of 3 stringers. And then, of course, that would really make it a lot stronger. In this video, I will show you how you can take a piece of paper and simply grab some measurements, scale them down, and then draw them on your piece of paper, and then measure the angle on that piece of paper, and then measure the line on that piece of paper to calculate your stringer length. So another way to do it, if this is going to be easier for you. So let's go ahead and start with a run of 5 foot 10 inches, or the length of the stairway, and the total rise, or the height between the levels, upper level, lower level, where we're going to have 4 foot 1 inch. And for those of you who might do a little better understanding what the stair stringer is going to look like for these measurements, let's go ahead and fill that in, along with the length of the board we're going to need to lay out our stair stringer. This will be the minimum length for these measurements. And let's go ahead and zoom out here. So we're starting with this right here to calculate the length of the stringer. And if you're starting with this right here and you're not working with a set of building plans, you actually have the measurements, you can lay it out on your project. You can simply measure from this point to this point. And if you end up with 7 foot 6 inches, you can buy an 8-foot piece of lumber for your stair stringers. However, if you have a set of building plans, or you're designing a set of stairs, and the Pythagorean theorem might be a little too difficult for you, just simply break these measurements down. I'm going to use 6 foot and go a little longer with this measurement, and then go 4 foot for this measurement here. And all I'm going to do is scale down the length of the stairway. Instead of 6 foot, I'm going to use 6 inches. And instead of 4 foot 1 inch, I'm going to use 4 foot and 3/16 of an inch, or forget the 3/16 of an inch and just use 4 foot. And when I draw that on my piece of paper, I'm just going to come off of the corner of the sheet of paper. This is a 90-degree angle on the piece of paper. So if I come off 6 inches and then go up 4 inches, I'm going to get 7 3/16 of an inch. And then I'm simply going to change this back to feet. Remember, this was 6 feet and 4 feet that I scaled down to 4 inches and 6 inches. So I'm just simply going to scale this up from 7 3/16 of an inch to just a little bit over 7 feet. And I don't think you can get much simpler than that without using the Pythagorean theorem, or actually measuring the actual distance on the job site. And if that doesn't make sense, let's go ahead and take an example where we might have 7 foot 3 inches and 5 foot 6 inches. I'm just simply going to break those measurements down to a fraction, because there are 4 3-inch increments in a foot. So if I had any measurement around 3 inches, I could use the 1/4 inch to scale down my feet to inches in the same way I could do it up here. 5 foot 6 inches would break down to a ratio of 5.5 inches. And if I measure the length on my piece of paper and it's around 9 inches, I know I'm going to need a 9-foot board. And I'm not about to suggest this is going to provide you with accurate measurements, but it's usually going to be close enough. Since I can't get a 9-foot piece of lumber, I'm going to get a 10-foot piece of lumber, providing me with plenty of room to lay out my stair stringers.